All right, pre-crack 11. Here we go. It's Mr. McPhee here. It's a beautiful May day, and we're about to do more trigonometry with sine law. So sine law part 1. We have done cosine law. Look back at the other video from the previous lesson on cosine law. This is sine law part 1. There's the practice that goes with it, which is part of the assignment in your textbook. And here is what sine law is. Sine law is basically dealing with non-right angle triangles, much like cosine law. The cosine law formula, remember, was the one that looked very much like kind of like a Pythagoras mix. So there's your cosine law. And it was used for, remember, side angle side or side side side. For any situation that is not side angle side or side side side, you'll use sine law. And it's a little bit different formula. It has kind of 3 parts to it. You only need 2 parts of the 3. So it's sine of big angle A divided by its opposite side length A is equivalent or equal to sine of angle B divided by its opposite side B. And that's also equal to sine of angle C divided by its opposite side C. Now, because there's 2 equal signs in this equation, you're only going to be using 2 parts of it. And I usually just write that out personally. Because remember, A, B, and C is, you're going to redefine that anyway depending on the circumstance that you're in. Some people write this also as they write the reciprocal of this, which you might see in some of the homework questions, but I just use this form and make my life simpler. So, just a recap of where you're going to use this. My easiest way of dealing with this is I use sine law when it's not right angled, and it's not cosine law, side angle side, or side side side. And the situations that come up with sine law for that would be, for example, if you had, say, an angle followed by another angle in a row followed by a side, which could be like angle, angle, side, or if you read it this way, side, angle, angle, and you may be finding out a missing side. So that's a sine question. Notice that is not SAS or SSS at all. And the other situation could be where you have 2 angles and then the side in the middle, so angle, side, angle. And then the one that we'll talk about in the next lesson, which is part 2 of sine law, this one literally is a pain in the angle, side, side, no pun intended. Because if you're given an angle followed by a side followed by another side, it is not SAS because the angle is not contained, so it's different than this situation. But this one does pose a little bit of a extra thinking that we'll talk about next class. So, or next lesson. So let's go through 3 examples showing you how to use the sine law formula. It's really quite straightforward. Here we go. So here's 2 examples. We'll start out with the first one here. They've given us a triangle where there's no 90 degrees given in that question. So I can't use SOHCAHTOA or Pythagoras. It's either then sine law or cosine law. Obviously it's sine law today because that's the lesson, but more importantly, if you didn't know what the lesson was or it's a random question, I've got an angle followed by another angle followed by a side. I can see that's angle, angle, side. That has to be sine law. And as soon as I see the sine law, I write out part of the sine law formula. I just use the A and B part of it. I don't need the equals C part because you're not going to work with 3 sides to an equation. And then now, you remember the big A and little a are just angle side opposites, so you just need to find angle side opposites. In this question here, we want to find this. So if you're looking for angle side opposites, like here's one obvious angle side opposite. So I could let this be angle big A, let this be little a. And then another angle side opposite, that's the only other one that's appropriate here, is this one, because you want this, you have that. I could make this my big B and this my little b. And notice the other missing angle side, this was big C if you want, and little c. I don't have it, don't want it, so it's kind of a useless pairing. So then I look at that, that's all I need. I go to my formula and I go, okay, what did I call big A? Big A was 30 degrees, so it's sine of 30 degrees divided by little a, 5, equals sine of big B, which is 70, over x. All right, so there's my setup. That's really, really important. So hope that's the most important part, because once you get to the setup, now it's just algebra. There's two ways to deal with this. Some people might take the reciprocal of both sides. They might literally flip both these sides head over heels and have the x on top. I personally don't bother with that step, but there's nothing wrong with it. As soon as I get this, it's now a proportion. So it's like this is to this as that is to that. I solve this just by cross multiplying. So I go x times this. So this multiplies this multiplies that. So I get x times sine 30 equals 5 times sine 70. And I'm one baby step away from having x. Divide both sides by sine 30. So you end up with this. Now be really careful with this. You never ever ever cancel out the signs. Never ever ever. All you can do is just go to your calculator. And the answer is whatever 5 times sine 70 is divided by sine of 30. So if I go to my calculator, make sure it's in degree mode. So 5 times sine 70. On my particular calculator, it puts a bracket in here. So I have to close, or it puts a bracket in the front, I have to close that off. So there's 5 times sine 70 divided by sine of 30. Enter. And now, okay, that's weird. Now I'm getting a really awkward answer there, because like, why? How can that be negative length? I know what the issue is because I've done this so many times. My calculator is not, there it is, my calculator is not in degree mode. That wasn't purposely done, I just grabbed this morning. So go back to degrees, make sure it's in degrees. Type in the exact same thing again, and there's my answer. 9.39 or 9.4 rounded to one decimal place. Does this look like it could be 9.4? Yeah. 70 is a wider spread angle than 30, so if this is 5 across, this is going to be bigger than 5 just by using logic. So there's my answer. X equals, let's go 2 decimal places. So that'd be 9.40. And the units, because I'm finding side length, would be centimeters. Done. So it's really quite quick. Once you get your angle side relationships linked together, there'll be always one unknown. Cross multiply, solve. It's much easier to use. The reason I'm doing this second though is because, like I said, there is a little twist to sine law that's coming that doesn't happen in cosine law. Okay, next example. I've got angle PQR. Angle R is 20, angle Q is 110. The length between R and Q is 10 meters. They want us to find side little r. And remember, little r is across from big R, so there's what I want. All right, so I look at it, ask myself, what can I use? No 90, SOHCAHTOA Pythagoras out. Sine law or cosine law? Well, I've got angle, side, angle. That is not SAS and not side, 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 so I know this is sine law. So right away, I write out the sine law formula. Don't even think twice. I don't care if it's A's and B's, even though I'm using P, Q's, and R's. I'll change that in a minute. All right. Remember, big A and little a, big B and little b are just letters they use. I could use big R's and little r's, big P's and little p's. That's nothing wrong with that either. What I'm going to do is go over to here and say, okay, first of all, what do I want? I want this. So if I want angle R, or side R, I'm going to have that pairing. So I might make this guy, I might make this my A in quotes, and this side my little a. Okay? No different. Just labeling it different. Now here comes the dilemma, is I need to find another angle side pair, but I've already got one unknown, so I have to find another angle side pair where there's no unknowns. But here's an issue. Across from 110, there's no length. I can't introduce another unknown. And across from the 10 meters, I have no angle. So at the moment, I'm handcuffed because I can't have two unknowns. But this is where it's sneaky. You know this angle here. Now it's only sneaky when the first time. If you have two angles of the triangle, you always have the third angle, because remember there's 180 degrees in all triangles, right angled or not right angled. And if you subtract subtract the 2. So 180 take away 110 is 70, take away 20 more. That has to, this I know. I know that's 50 degrees. They didn't tell it to me directly, but I worked it out. So now, if that's my 50 degrees, there's the winner. This has to be my angle side pair that I'll use. So this would be my big B, this would be my little b. And the 110 was useful. I needed it to get this angle. So it's not like it was useless. It had, just right now it doesn't have a moment where it's used there and done with. So then I'll go back to my formula and I'll type in, okay, sine of angle A, what's angle A? Angle A is in this case 20, the way we label it. Little a is R. And at side, sine B, little b is the 50. And little b is 10. And then I would just solve again by cross multiplying. So this times this, that times that. So 10 times sine 20. There's that cross multiplied. And the r multiplies over the other side. And then solve for r by dividing by sine 50. Sorry, my pen is dying. Too much use. Go to my calculator. And I kind of have an idea. If this is 50 degrees and that's 10, this is 20, this is going to be less than 10 meters, just by logic. So 10 times sine 20, close the bracket, divided by sine 50, enter. Let's round to 2 decimal places again, 4.46 meters is the length of little r. Hopefully that makes sense. Okay, before I do that, I'm going to do 4 examples. The third example we'll do the third example last, and we'll make up this fourth one really quick because I want to do one with an angle. So example number 4, even though I know we haven't done number 3. So let's say you have a triangle and you have a situation where you need to find an angle. So let's say you have a situation where this is, let's say, 30 degrees, this is 12 meters, and you also know this is, say, 10 meters. Now, we'll talk about this one in more detail in the second lesson, but I just want to make sure you're aware of this. And let's say you're wanting to find out, in this particular instance, you want to figure out this angle here. So I'll call that theta. So what do you have? You have an angle and 2 sides, but the angle is not contained. So this is not SAS. This is ASS or SSA. The books don't write this because it looks like they're swearing at you, donkey. So you know this is going to be sine law. Now next class we'll talk about, this is sine law with a twist, pain in the arse. So sine of A over little a equals sine of B over little b. I know I need this angle and this side pair because I need that angle that I'm finding. And then nice thing here is those are known. So there's my 2 angle side pairs. I could make this my A, my little a, make my B, my little b. Sine of big A, in this case is theta, divided by 10 equals sine of big B, which is 30, divided by 12. Oh, someone's phoning. And then from here, to solve for this is a little bit different. You're solving for this, you still cross multiply. So you're going to get 12 times sine theta equals 10 times sine 30. You want to divide by 12. Now sometimes people can jump right to here. I can do this really quick. I can almost just multiply the 10 across and get to this. When you go and type this in, you're not going to be done though, because notice this is sine theta. So you're going to go 10 times sine 30, 10 times sine 30 divided by 12. And you get this weird decimal 0.416 repeat. And then to get the theta, this is almost like a SOHCAHTOA setup, you do the second sine of 0.416 repeat. Second sine of that previous answer, and then out comes the angle of 24.6 degrees. Now, next class, next lesson, when you do have angle side side, which we do, there's a little bit more grunt work to think about on this one before you walk away. But at the moment, you walk away because you're done. All right? The last example, which we'll end up with here, is just a quick little, I'm not going to go through the full, well, we'll do it quickly here. You can fast forward through it. But what the situation is here is, here's a situation where you have a tree and there's a bird up there. I don't know if you can see my little bird that I drew. You are standing or sitting here and you look up at the bird and the angle of elevation is 10 degrees. You then walk 12 meters forward on a flat ground and you look up again and the angle now is 30 degrees because you're closer. With that information alone, could you figure out the height of the bird? And you can do this with grade 10 skills, but we're going to do a little bit of grade 11 in here as well. So when you look at this, you have three triangles. You have this right angle triangle here. You have a big right angle triangle there, and you have this smaller little wedgy triangle right here, which is not right angled. So to do this, I'm going to show you, I've already thought about the plan for this one. Sometimes you don't have a plan, you just kind of jump in and start finding things. If you look at this triangle here, which I'll call triangle number 1, you know this angle right here. Because remember, on a full line, there's 180 degrees. So this angle here is 180, take away 30. That is 150 degrees. And so now if I draw that triangle in its own little world like this, this is 12, this is 10, this is 150 degrees. Now you might look at that and go, well, how's that going to be helpful? The trouble is, to get to this height here, this triangle has only really not much information, just two angles. It would be really nice to have this length here. So I can use this picture here and say, well, I'm going to find out that length using this triangle. And I look at this and say, okay, angle side angle. Holy smokes, it's sine law. Out comes sine law. Looking here, I know here's my one angle side pair. So I'll call that big A and little a. This doesn't have a pairing with a number, but remember this, you know this angle here too. This angle is 180 degrees in a triangle, minus 150, minus 10. That is 20 degrees. Let me make sure that 30 minus 10, 20. Yeah. So there's going to be, here's my other angle side pair. There's little b, there's big B. So sine of 10 degrees divided by x, because that's my little a, is equal to sine of 20 degrees across from the 12. Cross multiply, choomp choomp choomp, you end up with x would equal 12 times sine 10 divided by sine 20. I did two steps there. I went this times this, that times that, and divided sine 20 out. Out comes my x. So 12 times sine 10 divided by sine 20. 6.09 blah 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 blah, and the units are meters. Now I'm going to keep all those decimal places there because I'm not done the question. So there's, I now know this length, which is good because now I can take this little right triangle here and look at it alone and say, hey, this is 30. This length here I know is 6.09 and change. How can I find the height? Now I have lots of options here. Because it's a right triangle, I could use SOHCAHTOA again. I could also use sine law or cosine law, whatever floats my boat. I'm going to use SOHCAHTOA just because I feel like it, because it's right angled. SOHCAHTOA would say label the sides. Okay, sitting here, you're the opposite, you're the hypotenuse, you're the adjacent. Don't care about that side, so O and H is sine. So sine of 30 degrees equals opposite H over hypotenuse 6.09 and change. Solve this by H is on the top, 6.09 times sine 30. And then I'll have the height of the bird. So 6.09 times sine 30. 3.046 blah 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 meters. So 3.0 meters if you want. Which is about a 15-foot tree. Not small. Probably could have measured it with a tape measure going this way, but that's a technique we could have used. So hopefully that question makes sense. If there's any concerns, drop me a chat email on Teams, and have fun working with sine law. Talk to you later.